I'm going to start by plugging this in, and then we're going to adjust the window so we have a good view of this. So the first thing I'm plugging in is, this is going to be the motion of the ball. And when I press graph, we are now going to adjust the window so we can see everything. Does everybody see how we have all this extra space over here? So I can see this goes out to about 1. I'm going to take away a lot of this stuff. So let's go to Windows. Let's go -3 to +3, and let's graph it. Would you agree right now that we have a better view of this? Okay, and I'm gonna do even more. Let's go to Windows and let's go -2 to +2. And now here's the problem. If I ask you to identify the maximum point, this is so close to the top that when we start to identify, it's going to be hard to see. So let's go up to Windows, and I don't need to have this bottom portion here. This is a real life situation. I'm only dealing with quadrant 1. Let's take away some of this and add to the top. I want to take away some of the negative y's and add to the top. Go to Windows. Let's go -5 for the y minimum, and let's go up to 15 for the y maximum. Okay, so this is the flight of the ball. It leaves the juggler's hand, and then at some point it's going to be caught 5.5 feet above the ground. What if the juggler reaches up to grab it and misses the ball? Then eventually it's going to hit the ground, right? Okay, go to y equals. Go to y sub 2, type in 5.5. This problem says identify the time it takes until the juggler catches the ball while it is descending. So here it is. The ball leaves the juggler's hands. It's still ascending, so don't find that intersection point. It goes up to the highest point. Now it's descending, and the juggler grabs the ball right here. We are going to use the intersection application on the calculator. Second, trace, intersect. Now use that cursor, and we're going to move it close to the second intersection point. It says first curve because that represents the first equation we plugged in. Press enter. It'll automatically jump to the second curve, which is the second equation we plugged in. Press enter. Now go over top of where they intersect and press enter. Okay, please circle where it says nearest 100th, because if you do all of this but you don't answer it correctly based on this, then I can't count it right. So this is like our x and our y, but in this problem you don't see an x, you see a t. So t is like our x. T is in terms of time, and it's in terms of seconds. So it says round to the nearest 100th. How long does it take till the ball is caught in the air while it is descending? 1.07 seconds. The key is descending, when it's coming down. So when the ball is 5.5 feet above the ground and the ball is descending, it is caught in the air. Okay? We're going to do a few more practice problems with this to prepare you for your test. You ready? Let's say the juggler's like me. We're not good at catching. Okay? We go up to catch the ball, but we miss the ball. The ball will eventually hit the ground. I want to know, rounded to the nearest 100th, how long does it take from when the ball leaves the juggler's hands to the time it hits the ground? So we're finding the 0. We're finding the x-intercept. Do second trace 0. So for this problem, left bound means above the x-axis somewhere. We press enter. Right bound is below the x-axis somewhere. And to guess, we go back. So if the juggler goes up to grab the ball and they miss it completely, the ball will eventually hit the ground. And if this question says, a scenario like I just described, how long does it take till the ball hits the ground? It would be approximately 1.34 seconds. Third question. What is the maximum height the ball reaches in the air? Go. What is the maximum height the ball reaches in the air? Second trace maximum. Is the maximum height the first or the second number? So if you have to round to the nearest hundredth, we would say 9.56. We have to come back here, 9.56 feet. Looking at the screen, how long did it take for the ball to reach its maximum height? How long? 0.56 seconds.